I'd like to thank you all again for taking the time to attend today's webinar. All of us here at ICP DAS USA are very thankful for all of our customers and distributors. I see a lot of familiar names out there, but if you're joining us for the first time, I'd like to extend an extra special welcome. Today, we are going to be talking about overall equipment effectiveness, or OEE. But first, a little business. You'll notice that all of the attendees are muted. If you have any questions, please enter them into the Q&A box, and we'll get to them during the Q&A session at the very end of the presentation. Please make sure to put your questions into the Q&A box and not the chat box. We're not going to be using the chat for this webinar. So I won't see your questions unless they're in the right place, which again is the Q&A box. So, a little bit about us. ICP DAS was established in 1993, and they are headquartered in Hsinchu, Taiwan. ICP DAS USA was launched in 2001 to support the North and South American markets and is located in Lomita, California. We have over 200 R&D engineers, and we work closely with them to add new features to our products, develop new products, and to support our customers. Most of our products are RoHS compliant, meaning they're lead free. We're also ISO 9001 certified, quality management certified in the UK, and we are a Windows embedded partner. I'd also like to take a little time to tell you about myself. My name is Colin McLeod. I'm one third of the marketing team here at ICP DAS USA, and I'm broadcasting to you live from my home in lovely, lovely Long Beach, California. My background is in marketing rather than engineering. So when it comes to today's topic, OEE, I am, of course, still learning, but I believe I'm qualified to give you the basics. I am not, however, Six Sigma certified. And the concept of OEE is a part of total productive maintenance programs, which are, again, part of the Six Sigma extended universe, we'll call it. So let's go over our agenda for today. We're talking about OEE. OEE is two things in my estimation. It is first a set of best practices and formulae for evaluating the efficiency of any process, really. We'll be talking about its applications in manufacturing, but can be applied to any business. And second, it is a paradigm, a way of evaluating problems, analyzing data, and devising solutions. We'll be talking about what OEE is and what it has to offer you as manufacturers, engineers, and distributors. Then we're going to get into implementation. OEE is a general framework, so it's up to the user to decide what's worth measuring and how to systematize the measurement taking. We're going to discuss this kind of implementation using a system that we devised at ICP DAS for measuring efficiency in a single machine or a single process. Then we'll talk about how you can apply data collected on the factory floor to the OEE formula. Concluding our discussion, I'm going to announce the winner of this month's $30 gift card giveaway. If you're following our newsletters, you'll have had a couple of chances to enter. If you're not subscribed, all of our contact information will be at the end, so you can enter for the next contest. All you need to do is go to our website, sign up for our newsletter, and you'll get the instructions in your email. And then finally, after the winner is announced, we'll open it up to a Q&A with our tech team. I have Steve here from engineering who will be able to answer any of the more technical questions that you have, specific questions about our products and implementation, that sort of thing. I just want to thank you all again for coming. Before we dive into OEE, I just want to know two things about my audience. The questions should show up on your screen through the Zoom interface. They're multiple choice. Won't take more than 30 seconds each. So first question, what is your job role? And just in broad terms, engineering, sales, management, or other. I'm going to take just a couple of seconds to answer this, and then we'll move on to the second one. I promise I won't torture you with these. Great. Thank you very much. we're going to move on to the second question. How familiar are you with OEE? Choices are very familiar, somewhat familiar, heard of it, and never heard of it. Okay, thank you. Very good responses. Thank you all. Yeah, this is just for me. Um, Good. So I can know how verbose I need to be in the following presentation. Okay, very interesting. Thank you again for answering my questions. Let's move on. So, what is OEE? Overall Equipment Effectiveness, or OEE, is a formula for determining efficiency, and it offers a few distinct advantages. One, it enables you to identify the source or sources of inefficiency, and two, it allows you to quantify the degree of inefficiency. OEE is a relatively simple formula that gives you a concrete number, a grade, if you will, that evaluates the efficiency of almost any process. It enables you to compare your performance to ideal conditions, to past performance, and to industry benchmarks. So, how does it do this? OEE tracks 6 categories of time loss and compares them to your ideal production times. It provides a formula that assigns a percentage efficiency score to 3 critical areas and then to your overall efficiency. The formula was designed to evaluate manufacturing efficiency, but you can apply it to almost any process or routine. You could even apply it to your own workflow in a personal or professional project. In a nutshell, OEE is a formula and a framework for identifying time loss and quantifying its overall impact. The formula is as follows: overall equipment effectiveness is equal to the product of availability, performance, and quality. So, we're going to talk about those 3 factors in greater depth just a little bit later. But first, I want to give you an example of how the formula works. First category: availability is equal to your operating time divided by planned production time, and then multiplied by 100 to give you a percent efficiency. So you get the equation: availability equals operating time over planned production time times 100. Planned production time is the total amount of time you have scheduled for production minus any planned stops. So in this example, we're going to be looking at a single shift at our imaginary widget factory. For this example, it's an 8-hour shift of 480 minutes. From there, we're going to subtract scheduled breaks to get our planned production time. In California, that would be an hour of break time per 8-hour shift. So 480 minus 60 equals 420. Next, we need to calculate operating time, which is planned production time minus downtime. And just estimating, we'll call it 90 minutes per shift for breakdowns, changeovers, and miscellaneous downtime. So 420 minus 90 equals 330. Our availability is equal to 330 over 420 times 100, which is about 78.57%. The next variable is performance. Performance is equal to total parts produced over operating time divided by ideal run rate times 100. So in our widget factory, we'll say that we produce 50,000 widgets in the 330-minute operating time that we derived in the first step. We'll say that our ideal run rate is 250 widgets per minute. So with this formula, we'll get 50,000 over 330, all of that over 250 times 100, which is about 60.60%. The last variable is quality. Q equals good parts produced over total parts produced times 100. So we produced 50,000 widgets in that last shift. We'll say 100 of them are rejected by quality assurance. And so you get 49,900 over 50,000 times 100, or about 99.8% efficiency. Putting it all together, we get an overall, okay, so you got 78.57 times 60.6 times 99.8, which gives us an overall efficiency or OEE score of 47.5%. So you can see how slowdowns and problems at each point in the production line compound to reduce your overall efficiency. For reference, an average OEE would be around 65%, and a target to shoot for would be around 85%. And those targets are going to vary depending on your industry. So, what does that leave us with? Where are these losses coming from, and how do we analyze them? Thankfully, OEE gives us a framework for understanding how efficiency is lost. These are called the six big losses, and two of each affect each variable in the OEE formula. Availability is affected by planned and unplanned stops. Performance is affected by small stops and slow cycles. Quality is affected by production rejects and startup rejects. And we're going to explain that in depth in the next slide, but I wanted you to have a look at these on their own. So, this is another way of understanding OEE as a matter of time loss. And I think this is a very helpful diagram for understanding just how each factor goes into decreasing your overall efficiency. So the first and largest chunk there at the top is all time, which is your theoretical production time, the amount of time you could work in a shift, a month, or a year if it were possible to operate nonstop at 100% efficiency. Planned production time is the time you have actually given to run your widget factory, an 8-hour shift, for instance, minus breaks. Net runtime accounts for, oh, sorry, that's right. I just got a little mixed up in my notes. All right. What are we talking about? Runtime. You get runtime by subtracting your availability losses. Availability losses include planned stops like maintenance, shift and production changeovers, cleaning, inspections, etc. Unplanned stops are breakdowns, lack of materials, tool failures, that sort of thing. Next, we have net runtime, which accounts for your performance losses. These include small stops like jams and other things that can be fixed by operators, misfeeds, material jams, blocked sensors, incorrect settings, etc. This also accounts for slow cycles, which can be caused by dirty or worn out equipment, substandard materials, operator inexperience, etc. Finally, you get your fully productive time when you account for quality losses. Quality losses consist of production rejects, which are defective parts produced during stable production, caused by things like incorrect settings, operator errors, and lot expiration in the case of food and chemical industries. And then there are startup rejects, which are defective parts produced from startup until stable production is reached. It's caused by suboptimal changeovers, equipment that needs warming up, or equipment that inherently creates waste after startup, like a web press. All right. I hope I've done a decent job of explaining OEE. It's not a difficult concept once you understand the jargon. OEE is an easy to remember formula that you can implement at a factory wide level or to a single machine. It's a good way of analyzing the points in your production process and finding where things are going wrong. And it shows in concrete terms how those issues compound to drag down your overall effectiveness. By using OEE, you can prevent production bottlenecks, identify weak links, and accurately measure your efficiency. Once you know where things are going wrong, you can apply a solution, and that's when you can start saving money. So, quickly, before we move on, I just want to ask another quick question, and that is, do you have an efficiency program in place? Your options are yes. We use an efficiency maximizing program in my workplace. And the second option is yes. We actually use OEE in my workplace. And third, no, we do not have a system. Okay, thank you very much for your answers. Moving on, moving right along. Okay, so now we're going to be talking about our OEE solution. And we have an example of a system that measures and displays an OEE score. So it's a solution that we developed at ICP DAS as a proof of concept and was designed to address one specific problem. So the trouble with OEE isn't understanding the jargon and formula, even I can do that. The hard part is interpreting world data in a way that makes sense according to the paradigm we've established. Collecting and analyzing data from the factory floor is potentially time and labor intensive, and that can only take place after you've decided what data are actually useful to collect. Implementing OEE presents upfront costs in terms of money and planning that a lot of manufacturers would find unacceptable for what is supposed to be a money saving process. So now I want to focus on the solution and one solution in particular. So here at ICP DAS, we put together a small OEE system that demonstrates how you can use technology to get live machine feedback and accurately measure efficiency. So what you're looking at is our demo kit. It's a proof of concept, not something that we sell out of the box. If you wanted an OEE system from us, we'd have you work with sales and engineering to design a custom system based on your needs. Most importantly, we'd want to leverage the data and sensor infrastructure we already have. Our modules work well with third-party products, so we want to take advantage of what you already have and integrate as seamlessly as possible. But enough of that. What you're looking at is the demo kit. It's designed to simulate production on a single line or a single machine. And let's dig into the system architecture. The most important thing to keep track of when you're measuring OEE is machine up and downtime. So here you can see we have a special data acquisition module that reads machine status from the stack light that you can see in the picture. And this is actually a 4-channel input module, so you can read the status from 4 stack lights. The stack light has 3 statuses: green, red, and flashing yellow. With this module, you can send the status to the controller and log the time, frequency, and duration of any of the 3 statuses. This will tell you how much time you're losing to availability losses and lets you know the time of the day and duration, both your planned and unplanned stops, so you can begin diagnosing problems and streamlining your process. As a note, the TSL P4R1 module that you see here has an alarm relay output feature. The next component is our DL10 temperature and humidity sensor. This is going to give you a clue towards 2 very important things: the causes and effects of equipment stops and slowdowns. If your machines aren't lubricated properly or are in need of maintenance, they're going to be generating excess heat. Conversely, you'll want to measure ambient temperature to make sure that all your equipment is running at recommended temperatures and to ensure that heating, cooling, ventilation systems are working down at the machine level and at different points on the factory floor. Because all of that is going to go into determining your performance score. Next, we have the M7084, which is a remote data acquisition module with 8 counter or 4 encoder input channels. You can use this to further measure machine performance by keeping track of RPMs, motion, speed, and frequency. You can also use it with IR sensors to count the total number of products produced and rejected in a given period, which will give you your quality score. The WISE 5231 is a smart PLC and data logger that, in this example, is actually running the simulation. It has a lot of different functions. For instance, you can implement if then else rules, log data, schedule functions, send alarms, and with an expandable I/O board, you can actually hook it right up to your sensor. So lots of possibilities there. The final component is our TPD 703. It's a touchpad controller and 7-inch monitor that, in this example, is programmed to catch all the data we're acquiring from the TSL, the DL10, and the M7084, measuring the downtime and uptime during the user-specified period, plugging the data into the OEE formula, which it then displays on the custom GUI that you can hopefully see on the screen there. That custom GUI was made with our HMI Works software, which is free with purchase of one of our HMIs. So the TPD 703 is a useful little controller. It has a 7-inch high contrast screen, provides a real-time clock. You can program logic controls with C and or ladder. Talks to your DAQ modules over RS-232 and RS-45. Talks to your SCADA over Ethernet. One very useful application of the TDP 703 for OEE is if you use it with an ACS or an access control system, you can go back into your data logs and compare your downtimes to the ACS to see who was operating your machines when. So let's sum it up. You monitor the operational status of a 3-color lamp on the production machine with the TSL-P4R1. The M7084 obtains data related to the production quantity and motor rotation speed. The DL10 measures temperature and humidity. At this point, you could also easily add another module to track your power consumption. These DAQ modules send info back to the TPD or to the control center, which performs your OEE calculation. Combine your physical data with a user access and maintenance logs, and now you are well on your way to identifying and diagnosing slowdowns, stoppages, and time loss all along your production line. The next step would be to replicate this system across all of your production lines, connect it all to SCADA in your control room, and now you have a factory-wide OEE system. It's easy enough to measure downtime with the right data infrastructure, but you want to go further if you want to start identifying patterns. If a machine is down more often than others, you need to know why. If it consumes more power, you'll need to know where it's losing efficiency. You need to keep track of who is running the machine, when, and for how long. You'll have to track maintenance routines and part replacements as you implement efficiency improvements. Not just a matter of greasing the squeaky wheel, but of tracking when, where, for how long, and ultimately why the wheel squeaks. And then you have to prevent it and others like it from getting squeaky in the first place. This is the goal of applied OEE, the ability to predict trouble and stop it before it becomes a problem. A system like this demo kit can help you do that. I hope that in this demonstration you can see something of a roadmap to planning and developing your own OEE systems. And of course, I'm hoping that you will come to ICP DAS USA to find the components you need to do that. In conclusion, OEE is an excellent framework for measuring a factory's most important performance indicators. OEE helps you identify problems, where they are in the line, and what's causing them. It quantifies the cumulative effects of these slowdowns in a way that is easily applicable. It gives you a hard and fast statistic that you can apply to measure your own progress and to compare with industry benchmarks. Okay, I want to thank everyone for coming. I had a lot of fun learning about OEE, actually. So I hope this was interesting and useful to you. If you're interested in our products, our contact info is there on the screen. If you want to know more, or if you want to talk about designing your own OEE solution, please don't hesitate to give us a call, 8 to 5 Pacific time, or send us an email at any old time. And as always, please do follow us on social media so you won't miss out on any of our upcoming monthly webinars. So in just a sec, if you have any technical questions, we're going to get into the Q&A with me and our engineer, Steve. But now I want to announce the winner of our $30 gift card giveaway. The winner of this month's prize is Alex Bernstein. Alex, if you are here, please raise your hand. You can see that on your Zoom control bar. Hey, there you are. Okay, great. So we will be in touch with you shortly to get you your $30 gift card. So thank you very much for participating. And if you are interested in participating in next month's contest, all you have to do is go to our website and sign up for our newsletter.